Hi, this is so we have openWSN running where on top we have the UDP application which injects two traffics at each 30 seconds. So on one hand we have this console which kind of shows you the information in scheduling, routing, everything in there, fragmentations, and so each packet is sort of divided into two fragments at least. And on the right hand side, this console is basically basically capturing the packets being sent, and it will do so for 1 hour. And this is being recorded here. So you inject packets, and the another console we had. So this application, we're just going to open that one just now. And this application, see here, is pretty much, so it's only capturing basically, it's not injecting payload or anything. So it's showing the slot durations 20 milliseconds, and experiment duration would be 1 hour, and information will be, so every 10 minutes it's sort of collecting the data. So here, and once this 1 hour window is over, it will plot the results. And that is what this application is meant for. Now by default, so these results are sort of saved in here, as you see, and they are used for plotting purpose once the experiment finishes. Now, the Open Apps in the firmware has one other application called uinject, and we are running it so we're running it in openWSN network. Now going back to the console, so we can enlarge it, and this is how the results are appearing from the capture. So it's every 10 minutes the data is being saved, and then we have sort of the actual openWSN output, and it's been running, I think it's been quite a while, so I'm sure it's going to be an hour soon. Now we're going to show you where the actual results are being saved. So because we're running Open Visualizer, in the Open Visualizer we have these two, packet info and packet payload. So we sort of created we edited that firmware application where we mentioned these two files, and they are sort of anything coming on serial is saving here. So just for the quick information, quick overview of what is being collected. So latency, source ID, number of TX and RX sales, counter, which is just the packets per each node, how many, so it increased by 1 each time or 2, and then you have ASN, which is actually the time, and the duty life cycle. Now we're going to sort of scroll it down and we'll see how many, what sort of the progress is so far. So we're seeing that we have 12, 14, so it's sort of gonna go anywhere until you want it running. So it goes 100, 200, so that would be showing like number of packets each device has sent over time. And yeah, so we're going to close that one. Then we're going to open the packet payload. In the payload we have average latency, and then we have the average cell uses and source ID, and then average PDR. So PDR so far is consistent and it's 100% is showing, but slightly decreased from what it was earlier. So this shows that some packets, a proportion packs being dropped, so 98%, and then going still all the way to 99. So it's maintaining. So that's basically happening when the topology was being formed. So the PDR is fairly above 99%. So and it's consistent, as you see. And the latency, as we spoke, that latency is over 3 seconds. So that 304.75 is basically that the value, it needs to multiply by 10 to show the actual time in seconds. So it's over 3 seconds each node is taking to send the packet when the slot durations to, sorry, yeah, that's right. So as you see, so far we have collected this much and it's still running, so we'll just keep this running for now. And the only problem is when I go away, this sort of the virtual machine sort of tend to go back to the sleep mode, which I need to sort of change. So speed monitor. Now I'm not going back to the this one. So you see that one there, I'm not touching any of those because last time I did and it threw an error and that sort of turned me down for everything I was doing. Okay, so let's just keep running, and this is just a short video how openWSN runs and how you can run the applications on top of openWSN, and how you can plot results and monitor the actual performance. We will discuss more about the scheduling algorithms in the next video, and we'll discuss the results in the next video.